Yeah, let's go to the next guy. So Bryson Sternock, are you online?
I'm here now.
Oh, Peter, it's working now? Great. Okay, please go ahead. 4 minutes.
Is my slide there?
Yeah, we can hear you.
Okay. Hi, everyone. Great to talk to everyone. Sorry I'm not there in person. My name is Peter. I'm a postdoc at Oxford. And I'm just going to briefly talk about combining machine learning and text for photometric redshift. So for many kind of contemporary and up-and-coming surveys, we're not going to have spectroscopic redshifts for our cosmological science, and instead it's going to be photometric redshifts. So have sort of 5 to 10-ish broadband magnitudes and try to map those magnitudes onto a redshift. So the kind of template spec method is a kind of highly sort of physically motivated, uses either empirical or synthetic galaxy templates and sort of shifts them and does a kind of chi-squared minimization style thing to see what redshift best. But there's also a sort of very data-driven approach that people have been studying for many years, where you take a sample of galaxies where you have both spectroscopy and photometry and try and learn the mapping using your favorite machine learning algorithm, and then make predictions for galaxies where you only have photometry. And both those methods work well, but have kind of advantages and disadvantages. And I've kind of been looking at ways of combining those. So basically trying to use the template fitting when the machine learning is reliable, and use the machine learning when the template fitting is unreliable. So based on how confident the machine learning is, not just in terms of the size of the uncertainty, but also using, I'm extrapolating too far, so the prediction is going to be unreliable. And I've kind of shown you can get superior predictions that outperform each of those individually. So the plot on the top left there kind of shows the red is the what template fitting would have predicted. Green is what you would have got from the machine learning, and then blue kind of shows the combined, and the black dashed line is what the true spectroscopic redshift was. So you can kind of use the machine learning as a sort of tiebreaker between different peaks in the PDF. And the bottom left shows the RMS for the 3 different methods, and it shows that the kind of blue, which is this combined method, can outperform each of them individually. So yeah, it's basically a way of trying to get the best of both worlds of your kind of physically motivated template methods and your empirically motivated machine learning methods to get the best photometric redshifts. Thank you.
Thanks very much, Peter. And so people can ask questions on Slack, and Peter can respond them offline. So